For this next setup, we are going to look at current measurements, right? So the drain current and the load current are probably one of the most complex measurements you can make on these setups. One, because you cannot break the loop. As soon as you add loops like this, it adds a lot of junk to your measurement that you shouldn't be looking at, right? One other way of doing the measurement is a shunt measurement, right? And it has its own drawbacks, right? So if you add a shunt, you have to make sure your losses are going to be okay. Your inductance that the shunt adds has to be really low, so you have to really find a nice low inductance shunt, right? But I want to show you an example right here which compares a shunt measurement versus a loop based current measurement on these designs. Now I want you to know this, this board was not designed for any load on it, right? So the current is super low, right? So it's not the best way of showing you this measurement, but we'll get some measurements to look at so that we can compare, you know, apples to apples. All right. So that being said, I got this TCP 30 amps 0030, right? And this is a 120 megahertz probe, right? So it's a pretty high bandwidth probe. It's not a slouch by any measure. And we'll use this to measure current on this lower side. So I can put a loop on this shunt. And on the high side, we are using the TIVM probe to go across the shunt, right? So that MMCX connector right there that says current on it is measuring current across the shunt, right? All right, so let's turn it on. Let's see what happens, right? So I'll turn the switches on, right? So you'll see some current. It's really, really small, right? There's not much load on it. There's just a capacitor. So it's not much, but we'll see the effects, okay? So let me change the scaling so you can see. What I can also do is, for reference, I'll turn on the VDS signal. So that is channel 3. So we know where it is turning off, okay? So we have a square wave to trigger on. And I'm going to change the trigger signal to my channel 3 right there. Okay, so we at least have a nice clean trigger. All right, perfect. Now that blue signal right there is the current measurement. We are using TIVM across the shunt to do it, right? So let me change the scale on that a little bit so we can see what's going on there, right there, okay? And don't worry too much about how the current looks. As I said, it's a very low load current, so it doesn't really mean anything, but I want to show you how the settling time looks and how it's different than a current measurement done via probe, right? So let's turn the channel 5 on and take a look at that, right? So you have your turning signal at the same point, right? But take a look at the settling time. Just compare this, and I'll put it so that it aligns with the probe. And just look at this. This is pretty cool. Okay, and then we'll bring it so it aligns just fine. And there you have it, right? So the blue signal is the one on the shunt, and the orange signal is the current probe, right? So we're measuring the exact same currents on both the circuits, right? But take a look at how different they look on both the signal, right? And this is really what the settling time of this probe is versus something like this, right? So shunt usually will give you a little better measure of what you're doing, and adding a loop never helps with this measurements. It's adding so much ringing on that circuit. This might also affect your VGS and VDS measurement, right? It'll just slow it down a little bit, right? So be very careful while using loop type measurements. Obviously your loop will be much shorter, but even then, just look at this. I mean, it just really affects your measurement, right? So don't do it, right? Shunt is probably a better way of doing it, but you'll have to be careful how many losses and how much inductance you're adding to it. The good part about shunt is you can design it in, so you know exactly what you're adding in, right? And you can depop it if you have to, right? So we'll close this section with this summary, and then we'll go to the next one.
Find out more at Vicom's website.